Okay, today we're going to look at one further type of growth model called a logistic growth model. If a population is growing in a constrained environment with a carrying capacity of K, an absent constraint would grow exponentially with growth rate R, then the population behavior can be described by the logistic growth model. P sub n equals P sub n minus 1 plus R times 1 minus P sub n minus 1 over K times P sub n minus 1. The carrying capacity is the largest population that an environment can support. So the bad news is there is no explicit form for this. So let's see how this example works. So write a recursive formula for the number of blackberry plants in the yard. P sub n equals P sub n minus 1 plus R, which is 200%, which would be 2, times 1 minus P sub n minus 1 over our carrying capacity, which is 50, times P sub n minus 1. Okay? Now let's calculate the number of plants after 1, 2, and 3 months. So P sub 1 would be P sub 0 plus 2 times 1 minus P sub 0 over 50 times P sub 0. P sub 0 was 10 plus 2 times 1 minus 10 over 50 times 10. We have 10 plus 2 times 1 minus 0.2 times 10. 10 plus 2 times 0.8 times 10. 10 plus 2 times 1.6 times 10. 10 plus 16. We have 26 plants. That is P1. P2 is going to be P1 plus 2 times 1 minus P1 over 50 times P1, which is 26 plus 2 times 1 minus 26 over 50 times 26. 26 plus 2 times 1 minus 0.52 times 26. 26 plus 2 times 0.48 times 26. 26 plus 0.96 times 26. 0.96 times 26 gives me 26 plus 24.96 or 50.96, which would be 51 plants. Now, recall the carrying capacity is 50. So what's going to happen? Well, something's going to die. So let's see how this works. Looking at P3. P3 equals P2 plus 2 times 1 minus P2 over 50 times P2. So I'm looking at 51 plus 2 times 1 minus 51 over 50 times 51. And 51 plus 2, 1 minus 1.02 times 51. 51 plus 2 times negative 0.02 times 51. 51 plus negative 0.04 times 51. gives me 51 minus 2.04, or 48.96, which we would round to 49 plants. So 2 of my plants died off. Okay, and then let's look at number 9 here. Suppose that you have a bowl of M&Ms, 500 M&Ms. E sub 0 equals 500. And each day you eat 1/4 of the M&Ms. 1/4 being 25%, or 0.25. Is the number of candies left changing linearly or exponentially? They have to say exponentially. Write an equation for the model. P sub n equals 500 times 1 plus, and it's decreasing by 25%, so minus to the n. So I have 500 times 0.75 to the n. That would be my explicit formula. And it turns out that when I did the recording for exponential, I forgot a problem. So let's look at this problem here. A native wolf species has been reintroduced into a national forest. Originally, 200 wolves were transplanted. After 3 years, the population had grown to 270 wolves. Population grows exponentially. Write a recursive formula for the number of wolves. The problem is we don't know what R is. So we can't write a recursive formula or an explicit formula. No, we can, but it won't be specific. So let's see what we can figure out. We know, going back to our recursive formula, we have P sub n equals 1 plus R times P sub n minus 1. P sub n equals 1 plus R P sub n minus 1. Is that right? Yes. That's for a recursive formula. So I know 270 equals 1 plus R times 2. Yep, I can't do that. I have to go P sub n equals P sub 0 times 1 plus R to the n. So 270 equals 200 times 1 plus 0. Nope, no, I don't know R. 1 plus R to the 3. So dividing both sides by 200, I get 1.35 equals 1 plus R to the 3rd power. I can take the cube root of both sides. On this side, I simply get 1 plus R. I can take 1.35 caret, open parentheses, 1 divided by 3, and I should get 1.1052. Subtract 1, and I get R is equal to 0.1052. So now I know this is simply P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals 1.1052 times P sub n minus 1. P sub n equals or our explicit formula, P sub n equals P sub 0 times 1.1052 to the n, and P sub 0 is 200. So now I can use this to find P sub 10. 200 times 1.1052 to the 10th. 1.1052 to the 10th. 1.1052 to the 10th power. You have 200 times 2.718997213. It gives me 543.7994426, which would be 544 wolves. Okay, now if this trend continues, how long will it take to have 1,000 wolves? So we would have 1,000 equals 200 times 1.1052 to the n. Dividing by 200, I have 5, plus 1.1052 to the n. Taking the log of both sides. Bringing down the 1, or the n. Log of 5 equals n times the log 1.1052. So n equals the log of 5 divided by the log of 1.1052. Again, using the calculator, open parentheses, log, which will open a parentheses, 5, close parentheses, divided by, open, log, it'll open, 1.1052, close, and you should get 16.09 years. And that finishes that.